day 60 of the year of streaming and learning to code. Today is the 1st of March, which marks the beginning of month 3 now. We are 85% of the way through Python. We have finally made it through section 10. Yeah, we did make it through section 10. Finished bitwise operators. And now we have 11, 12, and 13 left. The first lesson, Introduction to Classes, looked rather long, I'm sure, and that was just the intro to classes. I don't know how long classes will actually be, but if the intro was, I think it was 18 sections, pretty sure classes should be equally hefty. And for section 12, one lesson in that, and then the Python final project looks, well, frankly, hellish. Now, they've got upgrade now, so I'm not actually sure. In this project, you will leave Codecademy's learning environment to set up a development environment on your own computer. You will be able to apply your Python knowledge to build application, test it, run it. Be creative and show us what you come up with. Interesting. We'll see. Not sure why it says upgrade now if it's going to be something that I'd be doing on my own computer. So maybe that means we are extremely close to the end. Maybe that really only means there are 12 sections here within Codecademy ourselves. Kind of like, was it Git with the Amazon Web Services? That section was sort of a go it alone, if you will, for lack of a better phrase. You know, pursue that if you feel so inclined. Anywho, with that said, let's continue the party in section 11, Introduction to Classes. All right, and there are, yes, 18 sections. Hopefully we're able to make it like at least halfway through, maybe even the whole section. That'd be cool. But that's about it. So yeah, 18 sections, and it's pretty much go time. So from the top, why use classes? Hey, Topher, perfect timing. Right as we kick off this party. Very good. Hopefully your night's going well. Okay, we have class and fruit. I think we read some of this. We did read some of this last night, as usual. Well, we'll continue on. Why use classes? Python is an object-oriented programming language, which means it manipulates programming constructs called objects. You can think of an object as a single structure that contains data, as well as functions. Functions of objects are called methods. For example, anytime you call length Eric, Python is checking to see whether the string object you passed it has a length. And if it does, it returns the value associated with that attribute. When you call mydictionary.items, Python checks to see if mydictionary has an items method, which all dictionaries have, and executes that method if it finds it. But what makes Eric a string and mydictionary a dictionary? The fact that the instance of the string and dictionary classes, respectively. A class is just a way of organizing and producing objects with similar attributes and methods. I feel like that right there is the heart of the next 18 sections. Topher, hype for this section. Awesome, man. Oh my. Looking forward to finally getting a better understanding of object-oriented programming. OOP, or, as I'd like to call it, OOP. Yes, that's right, we went there. Instructions. Check out the code in the editor to the right. Blah. We've defined our own class, root, and created a lemon instance. When you're ready, click Save and Submit code to get started creating classes and objects of your own. So let's take a gander. We've got class, fruit, object. A class that makes various tasty fruits. Define init, self, name, color, flavor, poisonous. Self.name, name, self.color, color, self.flavor, flavor, self.poisonous, poisonous. Define, description, self, print, I am a blankety blank and I taste blank, self, color, name, flavor. Define is edible, self, if not self.poisonous, print, yep, I'm edible, else print, don't eat me, I'm super duper duper poisonous. Like, incredibly lethal. Lemon equals fruit. Lemon, yellow, sour, false. The false is throwing me off, but we'll see. Lemon dot description, lemon dot is edible. Fire away, damn it. I am a yellow lemon and I taste sour. Yep, I'm edible. Alright, we passed the lemon test. 1 of 18 micro dungeons down. That's what we're going to refer to them as today instead of lessons. Class syntax. A basic class consists only of the class keyword, the name of the class, and the class from which the new class inherits in parentheses. We'll get into the inheritance soon. For now, our class will inherit from the object class like so. Class, new class, object. Class magic here. This gives the powers and ability of a Python object. By convention, user-defined Python class names start with a capital letter. Like new class. Okay. Create a class called animal in the editor for now. In the body of your class, use pass keyword. Pass doesn't do anything, but it's useful as a placeholder in areas of your code where Python expects an expression. Hint, use the example in the instructions as a guide. Okay, create a class called animal in the editor. For now, in the body of your class, use the pass keyword. So I'm going to have class, animal, and then I think instead of object, I'm going to put pass. Shot in the dark, though. We'll see what happens. Class, animal, pass. Could be wrong. Maybe pass goes inside of it. On line 2. Yeah, inside of it. Okay, alright. Easy. We'll call it object. Those bastards. Object. Oh, missing a C. Object. And then, pass. Maybe that doesn't feel right either, but we'll see. Boom. We got it, little cat. We got it. Oh, look at you. What are you up to? Yeah, coming to celebrate? 1 section down? No, not section. Dungeon. Micro dungeon number 2. Conquered. Your tail is in the way, little cat. You're adorable. How about you? Yeah, nice. Moving? So close. Classier. Yeah, little cat. This is great and all. People love you. But there we go. I can see the screen. You're good. That's fine if you block the camera. Don't care about the camera. Just keep movement to the mic minimum and don't block the monitor. Okay, classier class. Classier classes, plural, right? Almost didn't catch that. We'd like our classes to do more than, well, nothing. So we'll have to replace our pass with something else. Your ass is in my face. Okay. We good? We're good? We're good. She's in my lab. We'd like to have our classes do more than, well, nothing. So we'll have to replace our pass with something else. You may have noticed in our example back in the first exercise that we started our class definition off with an odd-looking function init. Capitalize, or copy. This function is required for classes. It's used to initialize the objects it creates. Initialize always takes at least one argument, self, that refers to the object being created. You can think of initialize as the function that boots up each object the class creates. Remove the pass statement in your class definition, then go ahead and define an initialize function for your animal class. Pass the argument self. Pass it the argument self for now. We'll explain how this works in greater detail in the next section. Finally, the pass into the body of initialize definition, since it will expect an indented block. I was going to say very similar to this, but somehow we're cramming an animal segment somewhere in here. Your initialize function should look something like this. And you know what? Chances are the webcam is blocking the hint area, but that's okay. Instructions. Remove the pass statement from your class. Removed. Go ahead and define an initialize. So I can't remember the first one. Was it define here? Define class? I don't think it was. I think it was below. Define and initialize a function for your animal class. Pass in the argument self. Colon. Gut feeling says this is slightly off. Wow, really missing that colon key. Don't mind the save and submit thing. That's just to save the work. I want to check number 1 again. Look at your arm. Your tail is like wrapped up in my arm. So class aha define is inside. So that's why we were getting rid of pass. Pass was just noise. So we're putting in define blah blah blah. And that's why they want us to move pass within here for now. Very cool, very cool. 3, class here, class. We hit save and submit. Why didn't it save and submit? Those slimy bastards. Now, they had a comment online too. I'm going to go ahead and just do still space online too. So we've got define, initialize, colon, self. Very good. And then I think they wanted pass, but let's double check. Pass in the argument self for now. We'll explain how this works in greater detail. Finally, put pass into the body of initialize, since it will expect an indent, which we've given it. Save and submit. Beautiful, beautiful. On to section 4. Let's not get too selfish. Excellent. Let's make one more tweak to our class definition, then go ahead and instantiate? Is that? Yeah. Instantiate, create our first object. So far, initialize only takes one parameter, self. This is a Python convention. There's nothing magical. There's nothing magic about the word self. However, it's overwhelmingly common to use self as the first parameter in initialize. So you should do this so so that other people will understand your code. The part that is magic is the fact that self is the first parameter passed to initialize. Python will use the first parameter that initialize receives to refer to the object being created. This is why it's often called self, since the parameter gives the object being created its identity. Okay. I feel like this is going to turn into something bigger. Maybe that was the bigger thing and I just kind of missed it. Let's do two things in the editor. Pass initialize a second parameter, name, replace, or add. I think they mean add. Why else would it be second, right? Name. In the body of initialize, let the function know that name refers to created object's name by typing self.name equals name. This will become crystal clear in the next section. Your syntax should look like this. I am just going to copy this just so we can all see. This is the hint section. Copy. Hint. Blah, which I definitely saw. I totally get that. So I was right in my assumption, throwing name in there. And then we're going to be doing self.name equals name. Here in place of pass. We can get rid of this. Wow, little cat, you were just totally stretched out in my lap, giving up on life. Very committed. Also in the hint, they had definition right up underneath class, so we're going to get rid of the extra space. Here we go, next section, section 5, and it worked. Yay, green check mark. Okay. Instantiating your first object. This feels more important. Perfect. Now we're ready to start creating objects. We can access attributes of our object using dot notation. Here's how it works. Class, square object, define, initialize self sides 4. My shape equals square, print my shape sides. Okay. 1. First, we create a class named square with an attribute sides. Outside the class definition, we create a new instance of square named myShape and access that attribute using myShape.sides instructions. Outside the animal class definition, create a variable named zebra and set it equal to animal Jeffrey. Slightly confused, but that's okay. Then print out zebra's name. Click stuck, get a hint for an example hint. You can create a new animal object named Jeffrey like this. Zebra equals animal name Jeffrey. You can print out Jeffrey's name like this. Print zebra.name. Okay. I kind of feel like they just gave me the answer there, but once more, outside the animal class definition, okay, outside of this, create a variable named zebra and set it equal to animal Jeffrey. Well, that's exactly what this is right here, so I'm just going to copy that. Ta-da. You can, 2, print out the zebra's name, which would be zebra copy. Be print zebra.name. All right. So that worked. Next. I was way more interested in the square thing than the zebra fiasco, but I guess it's the same principle. That didn't exactly feel revelatory. More on initialize and self. Now that you're starting to understand how classes and objects work, it's worth delving a bit more into initialize and self. They can be confusing. As mentioned, you can think of initialize as the method that boots up a class instant object. The init it looks like it's written in English, but it's a lie. Python. Confusing. Plus, I'm struggling breathing for some reason. As mentioned, you can think of initialize as the method that boots up a class's instance object. The initialize bit is short for initialize. Okay. The first argument, initialize, gets used to refer to the instance object, and by convention, that argument is called self. If you add additional arguments, for instance, a name and age for your animal, setting each of those equal to self.name and self.age in the body of initialize will make it so that when you create an instance object of your animal class, you need to give each instance a name and an age, and those will be associated with the particular instance you created. Whew. Okay. Holy God. Hey, ephemeral. You think Python is confusing? Wait till you see Java. Java is confusing compared to Python. Yeah, well, I mean, their little intro to Java was... I felt like I didn't struggle too much with that, but they have the real version, or the more in-depth version of Java coming up. I think that's the second longest course they have. The Python course is 13 hours, which feels like, I don't know, 4 months now. The Java course through Codecademy is 10 hours. So, good. All right. Instructions. What are we doing? Check out the examples in the editor. See how initialize boots up each object to expect a name and an age. Then uses self.name and self.age to assign those names and ages to each object. Add a third attribute, is hungry, to initialize, and click the save and submit button to see the results. Your code should look something like this. Define, initialize, self-name, age, hungry, self-name, dot, blah, 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 hungry. Cool. Alright. Let's do that. Wow, what is all of this noise here? What is that? Hold on. Why is self-name and we put self-name and age, so we're adding... What am I adding? I'm adding is hungry to the majority of the work they already did for us for some reason. Class definition, class animal object makes cute animals. For initializing our instance objects, define, initialize self-name age, self.name, self.age. Note that self is only using the initialize function definition. We don't need to pass it to our instance objects. Zebra animal Jeffrey 2 true. Giraffe animal Bruce 1 false. Panda animal Chad 7 true. Not sure what the numbers have to do with anything, but I'm sure we'll find out. It's the age. It's the name, age, and whether they're hungry, which we will be adding in with the is hungry. Print zebra name, zebra age, zebra is hungry, name, age, hunger. Great. Okay. Very good. So let's take is hungry, copy, is hungry, self dot blah equals is hungry. They already did the name and age for us for some reason, so yeah, let's just do save and submit. Beautiful, right? Isn't that good, cat? Hey, look at me. No? You totally pass out. She totally passed out. Section 7. Class scope. Another important aspect of Python classes is scope. The scope of a variable is the context in which it is visible to the program. It may surprise you to learn that not all variables are accessible to all parts of a Python program at all times. When dealing with classes, you can have variables that are available everywhere, global variables, variables that are only available to members of a certain class, member variables, and variables that are only available to particular instances of a class, instance variables. The same goes for functions. Some are available everywhere, some are only available to members of a certain class, and still others are only available to particular instance objects. Okay, instructions. Check out the code in the editor. Note that each individual animal gets its own name and age since they're all initialized individually, but since they all have access to the member variable isAlive, since they're all members of the animal class, click Save and Submit to see the output. So we've got class animal objects, cute animals. isAlive equals true is shared by all. Then we've got define initialize self, of course, for protocol, and name and age. Self.name, self.age, isAlive is up here. So we've got, don't mind me, hold on. Ta-da. Crisis averted, all is well in the universe. Okay, here we go. Right, anyways, so isAlive equals true, since that'll be tied to everything. Within the function, define initialize self, it went over name and age, so it's got those two. Thus, when we do zebra, an animal, it only prints out those two, but when, not print, when we create the zebra variable, an animal, we reference the name and the age, but when we print, it has all three, name, age, and isAlive. Right? That makes sense. So all we have to do here is simply pull the trigger. Jeffrey 2 true, Bruce 1 true, Chad 7 true. That's great. Everyone's alive. Fantastic. Something about chat stuff. DAE class foo factory E extends bar extend to. What is that? Multiple inheritance should be 1 extends, should be bar 1 implements bar 2. I don't write Java, I don't know. Here's an example. This is a valid parameter in Java, class extends. Meanwhile, in Python, you have a equals 1. Ah, good. Well, if it remains that easy, I have no issue with that. If it's easy to pick up, that is fine by me. Section 8, or Micro Dungeon 8 of 18, right? Good times. A methodical approach. When a class has its own functions, those functions are called methods. You've already seen one such method, initialize, but you can also define your own methods. Pretty interesting, little cat? Perhaps not. Perhaps not. Let's keep going. Oh god. Totally dying, suffocating here. Instructions. Add a method description to your own animal class using 2 separate print statements. It should print out the name and age of the animals it's called on, then create an instance of an animal, hippo, with whatever name and age you like. Call its description method. Hint, remember to pass self as an argument to description, otherwise printing self.name and self.age won't work, since Python won't know which self that is, which object you're talking about. Your method should still look something like this. Define description self, print self.name, print self.age. After that, all you need to do is create a hippo and call its description method hippo.description. Kind of throwing me for a loop with the hippo thing, but I think I feel where they're headed with this. Class animal object queued animals is alive. Define name age self dot blah blah and age. Fire away. Class? No. Add a method description to your animal class. Define description self. Kind of going off their hint here, since I'm slightly uncertain. Okay. D. Totally blanking out. Alright, what are we doing? Define description self, print self.name. Is that print self.name, print self.age. Why wouldn't name and age? I still feel like name and age would be in there, but their example doesn't show that. Add a method description to your animal class. It's within the animal class. You know, those should probably be over. That looks better. Remember to pass self as an argument to descriptions. So we've defined description, we've added self. Add a method description to your animal class using 2 separate print statements. You should print out the name and age. Then create an instance of animal, hippo, with whatever name you'd like and call its description. Would it be hippo equals hippo.description? We're gonna run. Yeah, didn't like any of that. Good. I'm confused too. It seems like your code raises an error. See the console window for the error message. Trace back. Find most recent call. Line 1 in Python. And line 12. It's the hippo thing. Hippo's not defined. Doesn't like that. Doesn't like any of this. Although Animal Shere Khan 36, and that's a Jungle Book reference. Cause the following error to be erased. A local hippo reference. Interesting. What's going down in chat? Yeah, strongly typed, not even strongly typed. Just designed in a way that encourages arcane and convoluted design patterns. I know it's strongly typed, and I'm not saying that's the issue. Sounds like targeted Java. Haha. Hippo should not be inside the class. Well, in general principle, yes, hippos inside of a classroom would be bad. Seems like your code raises an error. See the console window for the error message. Line 12, hippo not defined. You know what? I should probably put self in there. Or... No. Also, instantiate the animal object before calling the description method. You need to initialize hippo. So... hippo equals animal. Okay. Hippo equals animal. Hippo 32. Huh. Hot damn. Okay, so I had class. We created class animal object. Comment makes cute animals. Cool. Is alive true for all critters within this class. We're defining. We're initializing. Self is the first. Oh god. Self goes in, which is normal. We've got name and age. Self.name, self.age. Add your method here. We defined description self. We printed self.name and we're printing self.age. Now outside of class, in reference to all that, we've got hippo equals animal hippo 32, which is the name and age. Okay. I think I follow. Let's check the next one. Not a very creative name, I suppose. A hippo named Hippo? Hey, we need to keep this as straightforward as possible. We don't want to confuse Steven, right? Remember, a class is just like a blueprint. Then you need to actually create the objects from the blueprint. Okay. We'll have to keep that in mind. Okay. They're multiplying. A class can have a number of member variables. These are variables that are available to all members of a class. Hippo equals animal, Jake 12, cat equals animal, boots 3, print hippo is alive equals false, print hippo is alive, print cat is alive. In the example above, we create two instances of an animal. Then we print out true. The default value stored in hippos is alive member variable. Next, we set that to false and print it out to make sure. 4, we finally print out true. The value stored in cats is alive member variable. We only change the variable in hippo, not in cat. Let's add another member variable to animal. We'll open a hint, move instructions up. After line 3, add a second member variable called health that contains the string good. After line 3, we'll be adding health, and that'll contain good instead of true. Then create 2 animals, sloth and ocelot. Give them whatever names and ages you'd like. Finally, on 3 separate lines, print out health of your hippo, sloth, and ocelot. You can add your member variable right under is alive like so. Health equals good, exactly what we were planning on doing. You can print out your hippo's health with... Oh god, no, getting tired. That's bad. That is bad. You can print that out with hippo.health or Steven.sleepy. Whatever works. Remember, class is just like a blueprint. You need to actually create the objects from the blueprint. I agree. The hippo should be named Gerald. Oh god, ephemeral. Too damn funny. Okay, we can do that. We can change the hippo's name to Gerald. And, what a great name. Okay. 32-year-old Gerald. Weighs roughly 7,000 pounds. I don't think hippos weigh that much, but that's alright. Probably 700 pounds is more accurate. Okay. What are we doing? After line 3, we were already discussing it. After instruction 1, after line 3, add a second member called health that contains the string good. So after line 3, health equals string good. Okay, that's down. Section 2. Then create 2 new animals, sloth and ocelot. Give them whatever names and ages you like. Oh, I'm creating. Nah. I'm creating the animals. Okay. So we've got sloth and ocelot. Ocelot is like a cat, right? Not a bird. Ocelot. Pretty sure it's of the feline. Yeah, see? Ocelot. Boom. Yeah, golden. Let's find a good one. Here we go. Good. Ocelot. No, wait, it's gotta be more than 7. I'm no hippo expert, but they look pretty damn heavy. Right, you know, I was thinking about that after I said 700. It's gotta be at least over a ton, which would be 2,000 pounds. Like, a hippo weighs a ton, kind of like even the phrase. So, similar to elephants, right? You know what? Hell, we're already on a tangent. How much does a hippo weigh? Hippo weight. This is all important. Oh, look at that. Males, 3,300 to 4,000 pounds. Females, 2,900 to 3,300 pounds. Hear that, little cat? Yeah. You know, the more you know, really. What happens if we click on this? Nothing special? Nope. Nothing special. Cool. Okay, we've got Ocelot. And, well, I mean, we've made it this far. Ocelots, hippos, and, sloths. Sloth. Yeah, look at that guy, right? He doesn't even know what's going on. Where are you going? Going nowhere. This dude, he definitely does not pay his taxes. Lazy bastard. Alright, and sloth in a teacup. Great, great. Okay, let's focus back on learning Python. Good. Good. Fascinating. Now, what are we doing? Sloth. Animal. Ba-dee-dee, dee-dee-dee. Bum-dum, ba-dum-dum. Be-dee-dee-dee-dee, dee-dee-dee-dee-doo. Number, doo-doo-doo. I know I should just be typing stuff in, but that's okay. Copy, dee-dee-dee, dee-dee-dee-dee, be-dee-doo-doo-doo. Okay, sloth. Topher, sloth with a Trump face just popped in my head. Name for a sloth. Sid. That's very, what's the movie? Jeez, Sid the Sloth. That's a thing. Ice Age. That's the movie. Ice Age. We're gonna do, 27. It's an older sloth. An ocelot. Good name for an ocelot. Jenkins. Yes. Proper name. Jenkins the ocelot. He is, boy, this is difficult. 19. Good. Good. This is a rough crowd. Hippo, or Gerald, Sid, and Jenkins. You don't want to come across those three in a back alley. Did you print the health of all three animals? I did not. I did not. I really should do comma good or something, or what did I need to do? Print. Finally, on 3 separate lines, print out the health of your hippo, sloth, and ocelot. So we've got print something dot health. Beautiful, beautiful. Hippo, sloth, and ocelot. It's going down. Topher, Ice Age, yes, yeah, good. Topher agrees with the Ice Age reference. Sid the Sloth, 10 out of 18. Maybe it's water. Maybe that's why I can't breathe. Dehydrated? Who knows? Breathing's for quitters. Just hold my breath, damn it. It's not all animals and fruits. Classes like animal and fruit make it easy to understand the concept of classes and instances, but you probably won't see many zebras or lemons in real-world programs. However, classes and objects are often used to model real-world objects. The code in the editor is a more realistic demonstration of the kind of classes and objects you might find in commercial software. Here we have a basic shopping cart class for creating shopping cart objects. For website customers, though basic, it's similar to what you'd see in a real program. Instructions. Create an instance of shopping cart called My Cart. Initialize it with any values you like, then use the add item method to an item in your cart. Oh god. Hint. Something or others. Since the shopping cart class has an initialize method. Oh, did we actually read the instructions? We didn't read the instructions. Create an instance of shopping cart called mycart, initialize it with any value you like, and then use add item method to add an item to your cart. Hint, since the shopping cart class has initialize method that takes a customer's name, I'd create my cart like so. My cart equals shopping cart Eric, calling add item method might then be my cart dot add item ukulele 10. I'm kind of seeing how this flows together now. Sort of. Copy, like right here, which was the hint. So we have our class, we're defining and initializing the self, comma, whatever else, laying out the self.customer name and all that. So we're defining, I guess, the function as it is. So that's really, and then we're creating, I guess, the variables. Like my cart equals shopping cart, we're referencing the values and other stuff, and then we actually go to print it or to do something with it, referencing another function like add item, or when we referenced health. I know we're still piecing it together, but I think I can feel the connection, the understanding. Yeah. The understanding of how this works forming, roughly. That's currently where I stand. Oh, for allergies. Oh yeah, long time allergies. Just breathing's overrated in my book. Plus, it doesn't help living with 3 cats. So you know, but that's okay. Here we go. Create an instance of shopping cart called my cart. Initialize it with any values you like, then use add item method to an item in your cart. So where would I put this? I guess just right below define. So I'd do my cart equals shopping cart? Question? Maybe? Now, what do we, customer's name? So what do we have so far? So we have class, we have shopping cart object, creates a shopping cart objects for users of our Find website. Items in the cart is blah, doesn't matter. That's going to be for all definitions, or for all functions. So this function, the following, they can all reference items in the cart. This particular function deals with initializing the customer's name. Self.customer name. Add item deals with self again, product and price specifically. Add product. If product and self items in cart, self items in cart product equals price. Print product and added. Else, print product is already in the cart. Okay, so it can figure out if it's in there or not. And then remove item dot self, of course, and product. If product in self item is in the cart, delete self items in cart, print product has been removed. Else, print product is not in the cart. So we can tell if it's in the cart as well, and if it's not, so vice versa. Very handy. So we're doing my cart equals shopping cart, the customer's name, since we're referencing that. Go to Kyle or Timmy. We'll call him Timmy. Instantiate the objects outside the class definition. Back this up. Boom. There we go. Outsided. My cart, shopping cart, Timmy. and then initialize with any values you like, then use the add item method to your cart. So my cart.add item. I think there's an underscore. Yo-yo? $4? Who knows? Who knows? Timmy bought a yo-yo for $4. Yeah? God, I hope that's okay. Yo-yo added. Damn straight. Okay, we got lucky with that one. Inheritance. Yeah, 11 out of 18. Not bad. Not bad. Okay. Warning. Here be dragons. Inheritance is a tricky concept, so let's go through it step by step. Inheritance is the process by which one class takes on the attributes and methods of another, and it's used to express and is a relationship. For example, a panda is a bear. Your claws are in my calf, little cat. Good God. And you're sleeping, so you're unconscious, so you can't control your claws? Okay, that hurts. Let's just move them there. Better. Good. Okay, something about pandas. Inheritance is the process by which one class takes on the attributes and methods of another, and it is used to express and is a relationship. For example, a panda is a bear, so a panda could inherit from a bear class. However, a Toyota is not a tractor, so it shouldn't inherit from the tractor class, even if they have a lot of attributes and methods in common. Instead, both Toyota and tractor could ultimately inherit the same vehicle class. Alright, I can follow that. I can see that. That makes sense. Instructions. Check out the code in the editor. We've defined a class customer as well as a returning customer class that inherits from customer. Note that we don't define the display cart method in the body of the returning customer, but it will still have access to that method via inheritance. Click Save and Submit to see for yourself. Little cat I have to turn. Okay. What are we doing? We are clicking Save and Submit after we take a look at this. Class customer object produces objects that represent customers. Define, initialize self customer ID. So we've got self customer ID, and we're defining display cart itself. Print, I am a string that stands for the contents of your shopping cart. Sure, we'll give them a pass on that for now. Class returning customer, which references customer for customers of the repeat variety. Define display order history self. I'm a string that stands for your order history. Monty Python, ha ha ha. Returning customer ID 12345. Monty Python display cart. Monty Python display order history. Fire away. I'm a string that stands for contents of your shopping cart. I'm a string that stands in for your order history. Beautiful. Now we get to hack away at this ourselves. Inheritance syntax. In Python, inheritance works like this. Class, derived class, base class. Code goes here, where derived class is the new class you're making, and base class is the class from which that new class inherits. On lines 1 through 4, we've created a class named Shape. 1. Create your own class triangle that inherits from shape like this. Class triangle shape. Code goes here. 2. Inside the triangle's class, write an initialize function that takes 4 arguments. Self, side 1, 2, and side 3. 3. Inside initialize function, set self side 1, side 2 equals side 2, and same goes for side 3. Click stuck, get a hint. Your code should look something like this. Class triangle shape, define initialize sides 1 to blah, blah. Lovely, lovely. So, go time. Class triangle inherits from shape colon. We've got define initialize init underscore colon for that, and self comma side 1 side 2 side 3. Well, there's no S in that. You lazy. Okay, here we go. Gopher, you've been doing inheritance the entire time since every class you've written so far inherits from the object base class. Oh, clever. Okay, yeah, gotcha. Interesting. That makes sense. Alright. So, let's finish this off. Let's do, what's that? Self dot side something 1 equals side 1. Yeah. Self dot side 1 equals side 1 copy. But we're gonna do 2 3 2. Oh god, on a rampage. 3. That seems reasonably okay. Save and submit. Boom. Green check mark. In the bag. 13 of 18. Override. Sometimes you'll want one class that inherits from another to not only take on the methods of... Whoa. Hold on. Override. And lack of oxygen. Whichever happens first. Okay, override. Sometimes you'll want one class that inherits from another to not only take on the methods and attributes of its parents, but to override one or more of them. Class employee object. Define initialize self-name, self.name, define greet self, other print hello, other name. Class CEO employee, define greet self other print, get back to work, variable other name. CEO is Emily, employee is Steve, employee greet CEO, hello Emily, CEO greet employee, get back to work Steve. Well, that's just extremely relatable. Rather than have a separate greet underlining method for our CEO, we override or recreate the greet method on top of the base employee.greet method. This way we don't need to know what type of employee we have before we greet another employee. I'm going to read that last bit once more. Rather than have a separate greet underling method for our CEO, we override or recreate the greet method on top of the base employee.greet method. This way we don't need to know what type of employee we have before we greet another employee. Okay, I think I get that. Instructions. 1. Create a new class, part-time employee that inherits from employee. 2. Give your derived class a calculate wage method that overrides employees. It should take self and hours as arguments because part-time.employee calculate underscore wage overrides employee.calculate underscore wage is still, it still needs to set self.hours equal to hours. It should return the part-time employee's number of hours worked multiplied by $12. That is, they get $12 per hour instead of 20, which, yeah, makes sense. That's fairly straightforward. Hint. In the example code above, we created an overriding CEO.greet method. It had the same argument as employee.greet. You'll want to add calculate wage method to your part-time employee class, and it should also take self and hours as arguments. Instead of returning hours times 20, though, it should return hours times 12. There's a high probability we're going to run into issues on this one. Let's take a look, though. So far, we've got class employee objects, models real-life employees, define initialize self-employee name, self.employee name, blah. Define calculate wage, self, comma, hours, self hours, return hours, 20. Add your code below. From the top. And that's their example. If we need to reference that, that'll work. We've got some stuff here in the hint, but we're going to focus on the instructions for now. 1. Create a new class, part-time employee, that inherits from employee. Class, part-time employee, employee. Define, initialize, self, give your derived class a calculate wage method that overrides employees. So, calculate wage method that overrides employees. It should take self and hours as arguments. Maybe I'm doing that wrong. See, this has a calculate wage. And that has self and hours. Give your derived class calculate wage method that overrides employees. Because part-time.calculate wage overrides employees.calculate wage, it still needs to set self.hours equal to hours. I think I don't necessarily need the initialize thing here. I think I can just do the define calculate wage, self and hours. Below it. Copy. I think that flies. Because part-time dot employee calculate wage overrides that, it still needs to set this. It should return employees' number of hours worked multiplied by 12. That is, they get $12 an hour instead. Instead of returning 12 by that, it should return hours times 12. I don't know if I'm missing anything, but I just kind of want to pull the trigger in the meantime, see what errors we get. Okay, so that's okay. I still, even though it's correct, I don't know if it could be cleaned up more, but let me see. Topher said something. Get rid of your initialized in your derived class. Get rid of the initialize. Oh, I think you were talking about, that's probably a slightly older call. I think he was talking about when I had, initialize down here earlier, I think. But that's gone. And we got the green check mark, so all is well in the universe. At least in section 13, mostly. 14 of 18. I'm surprised I've made it this far. Did something change? I don't think I ate anything differently on day 59 or day 60 than the other days. Usually there's more crying involved. We've made it 14 sections without having a meltdown. Kind of takes the fun out of it, right? Although it certainly makes it way more pleasant to learn. I've also noticed that just the instructions, the writing of the anecdote/story, the instructions themselves, and hints, with how they're written and the relevance is also way better in this section. They had some other person write this bit than whoever else has been in control of all this other stuff. So, Topher, you got through binary and bitwise. OP's a breed. That's true. We did come out. We came directly out of hell into this. It's probably just comparing it to binary. You're probably right. This is probably just as annoying as everything else, but after doing the binary stuff, this seems like a friggin' cakewalk. Alright. Let's not lose too much momentum, though. Let's continue on. This looks like a job for ellipses. On the flip side, sometimes you'll be working with a derived class or subclass. Laser beam. Alright. And realize that you've overwritten a method or attribute defined in that class base class, also called a parent or superclass. I need to create a line of either Mother's Day or Father's Day cards that reference them as superclass. Have a superclass Mother's Day. That we're hitting the wall. We've reached the point of not just bad jokes, but terrible jokes. This is a good sign. Alright. Something about something. And we've lost interest in all motivation. Good. Insanity is starting to settle in rather quickly. Here it goes, once more. How quickly the tables turn. On the flip side, sometimes you'll be working with a derived class or subclass and realize that you've overwritten a method or attribute defined in that class base, also called a parent or superclass that you actually need. Have no fear. You can directly access the attributes or methods of a superclass within Python's built-in super call. The syntax looks like this. Class derived base, define m self, return super derive self.m, where m is a method from the base class. We've done preparations A through G, now it's time for preparation H. Oh good, I'm glad someone got the laser beam reference. Okay. Bless you. Issue. Okay. Instructions. First, inside your part-time employee class. Whoa. First, inside your part-time employee class, within this bit, add a new method called full-time wage with the argument self and hours. Very similar to this, I take it. 2. That method should return the result of supercall to calculate wage method of part-time employee's parent class. use the example above. I think they're talking about returning hours times 20. Then, after your class, create an instance of part-time employee class called Milton. Oh my god. Don't forget to give it a name. Finally, print out the result calling his full-time wage method. You should see his wage printed out at $20 per hour. That is for 10 hours. That should, the result should be $200. All I can think of, Milton in Office Space. My stapler. Oh, there's a person there. She's been there the whole time. No, it's, when I had to do the camera thing and mute the mic, or that was me pointing at there's the mute button. So that's why I do all the stuff. The thing. Either I'm coming or going, or people are coming or going, or I have to go yell down the hall. There's lots going on in a household with 3 cats and multiple people. Yeah, that's a thing. There's party never stops here. Hey, and little kitty's awake. Are you actually moving, or are you just repositioning for your nap? No. You were just getting all kinds of snuggly. Alright. So yeah. What's happening? We made it through. Then after your class, create an instance of the part-time employee class called Milton. Don't forget to give it a name. And I saw your I said no salt or big grains of salt. Yes, red stapler and all. Two, finally, print out the results of his full-time wage. We read this bit. $200 an hour. Hint. Your super call should look something like this. Define full-time wage, self hours, return, super part-time employee, self dot method, args. I'm not sure what the args is. We'll need to look into that. Where method is the method you want to calculate, and args, are the arguments that the method takes. Interesting. You know, we're going to type that out. Let's do this. Baby steps, though. Baby steps. Instructions. First, inside your part-time employee class, add a new method called full-time wage with self hours. Copy. Full-time wage. Hold on. The dynamics of having multiple people in this room. Okay, finally. Crisis averted. Had to go record things for like 3 different shows for other humans, specifically mother-in-laws. Meh. Yeah, no. Ephemeral, on the right path. Mother-in-law. Yeah. Fusion. The trifecta. Or I guess that's only 2 factors, but still brutal. Okay. We were doing something with wages. We were doing so good. But we totally got sidetracked. Having to DVR crappy TV shows. Then, what are we doing? Okay, so we did this. We got full-time wage, self, and hours. Define full-time wage, self, and hours. With argument, self, hours, beautiful. That argument should return the result of a super call to the calculate wage method of part-time employees parent class. Use above for help. So define that method should return so copy. It should return super m self and part-time. Did I read that right? I think I read that right. Okay, and now something about someone. Then after your class, create an instance of the part-time class called Milton. Create an instance of the part-time class. Whoa. After your class, create an instance. Milton? Is that what they mean? Don't forget to give him a name. So part-time employee. Milton. And what's going down? You aren't done with step 2. Oh, I'm not done with step 2? And don't forget 2 spaces after your class definition for PEP8. 2 new lines. 2 lines. And I'm not done with step 2. That method should return the result of a super called to the calculate wage method. Maybe that's my issue. Maybe it needs to be super calculate wage of part-time. Maybe it's calculate wage dot part-time employees. Self M? Just a joke. Ah. Right. Good. Good. 2 new lines. Still missing something. Part-time employee self method. In the hint they mentioned, was that for full-time? Yeah, method. Now they had dot method, but argument, where method is the method you want, calculate wages, and args are the arguments that would take its place. The cow. Oh, I'm replacing the M with calculate. And hours is the argument. Okay. So I was trying to figure out their hint. Which was dot method. But it was dot M here and dot M up here. So I was trying to figure out, one, why I realized the M stood for method, but I couldn't figure out why they had typed it out fully. So that means this becomes calculate, as you were saying. And then the actual argument that I put in there, argument would be hours. That makes sense. So instructions, calculate wage. And then hours. Replace M, calculate wage, don't forget. Don't mind me. Hella sneezy. Everyone hit the decks. It's like my face is exploding. Dear God. Probably after having the cat all over me. This is what I get for trying to love that stupid creature. Okay, so we made it through part 2. Now we're dealing with the Milton instance. Create an instance of the part-time employee class Milton. Don't forget to give it a name. Finally, print out the result of calling his full-time wage method. You should see his wage printed out as $20 per hour. Oh, so now I should do very... Finally, print out the result. So now I should have a print Milton thing in my life. Print... Print Milton full-time wage. Uh-oh. Let's see how that goes. Let's see how that goes. Your code raised an exception. Have a look at the console window for the error message. Traceback, Python, line 22. Full-time wage is not defined. Call a method of a class using the dot operator. Oh, Milton dot full-time wage? Is that what it was? God, now I'm drawing a blank on it. How to do... Haha, there we go. That was close. But why does it look so ugly? Bound method part-time dot full-time wage of part-time employee object at blah blah blah. Kind of seems like that is for $10 an hour, the result would be $200. Did I miss something? Should it say? I feel like it should have printed 200 instead of all this. Perhaps not. Yeah, you could clean up the argument on line 22. Oh, yeah, so I just needed to give him a name, I think. Close. I thought there was going to be more. My bad. Save and submit. No, that's also ugly. Huh. Well, they gave me the green check mark, so I kind of want to take it and run. We do that? Let's take a look at 15. Maybe 15. Yeah, look at this. Look at how nice 15 looks. And 15 is closer to 18 than 14 is, which is always nice. Class basics. First things first, let's create a class to work with. Create a class triangle that its initialize method should take self, angle 1, angle 2, angle 3 as arguments. Make sure to set up these properly in the body of the line initialize method. See the hint, blah, 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 blah. Make sure your triangle inherits from object. Remember your class syntax looks like this. Class name, object, define, initialize, arguments. Fire away. Could clean it. It's not right. Oh, God. Topher, you're so good. Damn it. It's not right. He's right. It's wrong to leave it. Just because it's not bleeding out doesn't mean we could do a better job. Imagine if we were training to be a doctor, right? Our patient would be walking out of the hospital looking like this. That's not really acceptable by anyone's standards. Just because they're alive doesn't mean they'll survive. Okay, so here we go. Let's close out Ocelot nonsense and the hippo fiasco, as well as the sloth issue. We've got something about something. Milton Dot, full-time wage 20. Oh. Is that what's happening? $400. Why is this dude walking away with... Oh, well, time. Are they doing per week? Is it $200 a week? So $400 every paycheck? Is he getting paid bi-weekly? Maybe he's getting paid bi-weekly. I was just expecting to see a 200, not a 400. Dee 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 dee. 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 Try 10 instead of 20. Makes $20 an hour. Oh, so that was the hours slot. It was the hours slot, guys. That makes lots of sense. $200 for 10 hours. Okay, that we can live with. All is well. Milton crisis averted. Class basics. First thing first, the triangle fiasco. Class. Triangle. Something about something with a thing. Do we just do something generic, like object? We are going to define, initialize, parentheses, parenthesi, self, angle 1, angle 2, angle 3, we have more to do. Do I put pass as a filler? Let's try. Now what happens if I don't have pass? It still works, but it doesn't like this. So path helps avoid the errors. Or pass, not path. Pass helps avoid the errors. All right, class it up. Now let's add a member variable and a member and a method to our class. Inside the triangle class, create a variable named number of sides. Set it equal to 3. Copy. Variable. Whoa, whoa, whoa. Hold on. Let's keep reading before we do anything rash. Inside the triangle class, create a variable named number of sides, set it equal to 3, create a method named check angles. The sum of the triangle's 3 angles should return true. If the sum of self.angle 1, 2, and 3 is equal to 180 and false otherwise. Okay, true if the sum equals 180, false otherwise. Okay. Hint, check the angles method should look like this. Something, 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 180. Or you could set angle 1 through 3 properties of the class self dot angle n equals angle n. Or you could set angle 1 through 3 properties of the class self dot angle n. Okay. I'm going to do 2 versions. First, I'm going to spit out what my mind can currently process, which looks very similar to what they've got in their instructions. And then I'll piece yours together. Yours seems a lot faster and more straightforward, but I'm not that clever for some reason. Okay, define. What am I doing? Number of sides. If... No. Create the variable first. Create the variable. Number of sides equals 3. Create a method. Check angles. Check angles. And define. Check. Self. I think. Okay, we've got if self dot angles 1, 2, 3, 180. So it should be very similar to that. put the number of sides property above the class constructor. I think he means, ta-da, put the number of sides property above the class constructor initialize. Could set angles 1 through 3 of the class angle n equal to dot n. I still want to piece that together. I'll get there. I'll get there. Baby steps. Okay. And if it's equivalent to 180, colon, return true, else return false. Now there's probably more work to do, but I want to see where we stand. Yeah, check angle self. I think I should have triangle, if I'm not mistaken, instead of self. Also bad. Just kidding. That was a joke. Inside the class constructor, you need to initialize angle parameters and assign them to class properties. So self.angle1 equals angle1. Oh, right. Totally forgot about that. There we go. There we go. Now there's more to piece together. This is good. That was helpful. In your check angles method, make sure to check the sum of the angles. Self 1, 2, 3. I think it's the fact that there's no spaces between them. I don't know why they didn't have spaces between. Maybe the spaces don't matter, but every other time I've seen equations, I've always seen spaces. Definitely not the issue. In your check angles method, make sure to check the sum of self.angle1 plus self.angle2 and self.angle3. And that's good. To do that, I need... It's the S. I've got an issue. It's because I have angles versus S. Topher... Yep. Topher saw too. You've got angles instead of angle. I wonder if it's easier to just add the S to these, but I don't know if they're going to be a stickler about it, and if they want, you know, for the purpose of the instruction. Oh, they don't care for the purpose of the instruction if it's plural or singular. So look at that. There we go. Okay, and I gotta remember to do that next time. Define self and any attributes, whether it's name or angles or age, to reference them. Initialize them. Self.angles1 equals angle. You know, and that still was not very accurate. There we go. Now everything has angles. Angles, angles, angles. All plural. Because it still ran even with these guys as singular. We're going to run it once more. Aha, look at that. Look at this. So, check your angles, make sure the sum of self angle 1, 2, and 3. We changed angles, plural, or from singular to plural. Cat, you gotta move just a little. Actually, not in this direction. Hold on. See? So it has something about these values right here it's looking at. Whiskers, you're great and adorable and all, but how about you go over here? No? Holy God. Okay. So, we're gonna... Okay, there we go. All good. Crazy cat. Alright, we're gonna change all of these to individual. Singular, angle. No S's in this part of the world. Angle, angle, angle. Let's try again from the top. For reals. Why doesn't it like... I'm totally at a blank. Sides. Check the triangle method argument. Should be self, not triangle. Ah, gotcha. Because it was self before. There we go. Okay. So, singular angles across the board and self in the check angles function. That's what was needed. Finally. 17 of 18. We are right there on the edge. Little cat, you keep just moving everything. Okay. We've got... instantiate an object. Let's go ahead and create an instance of our triangle class. Create a variable named myTriangle, set it equal to a new instance of your triangle class, pass it 3 angles that sum to 180, 90, 30, and 60, print out myTriangle dot number of sides, print out myTriangle dot checks angles. Hint, remember, so we can instantiate an object like so, instance equals class and argument, where argument is the arguments initialize takes, not including self. Okay, let's see if we can piece this together without crying. Create a variable named myTriangle. Set it equal to a new instance of your triangle class. Okay. myTriangle. Create a variable named myTriangle. Equal. Set it equal to a new instance of your triangle class. Pass the 3 angles to sum to 180. Why do I seem... I feel like it's supposed to be like my triangle or a dot in front. Well, you know, but triangle spelled correctly. Triangle or something or other here. Dot something triangle and then the angles like 90, 30, comma 60 or something or other, but I don't know why. That seems wrong. Seems like the right direction in general. The easy part of this is my triangle number of sides, copy, print, and print. Those are the easy parts. Check angles though. Ooh, check. I think it's gonna be checking sides. I'm gonna be checking sides 1, 2, and 3. Maybe it's just angle 1, 2, and 3. Or 90, 30, and 60 of some combination going there. We'll see. We'll piece it together. Instance equals class argument. Check the angles method argument should be self. Oh, that was for last one. Instance equals class and argument. Okay, just focus on that. Don't throw where arguments are the arguments of initialize, and it takes everything except self. So here, we had number of sides initialized, so it'd be angles 1, 2, and 3. That's the arguments it's taking. One, 2, and 3. Check angles method has no arguments, no need to pass anything, just leave parentheses empty. These guys get angles 1, 2, and 3. That's what's going on. And we don't need the my dot, it just is that triangle, angle 1, 2, and 3, number sides, check angles empty, there we go. Did you create an instance of triangle called my triangle? No. Did I do it wrong? Line 14 is wrong. Also wrong. Okay. Alright, so the instance equals class and arguments. We have the class, we have the argument. Triangle, angle 1, 2, and 3. Create a variable named myTriangle and set it equal to a new instance of your triangle class. Am I calling it triangle again? Wait, that doesn't seem right. Nope, line 14 is wrong. Change it to accept values 90, 30, and 60 again. Oh, my triangle. 90, 30, 60. Okay, so one of my 45 guesses was correct. That's not exactly helpful in real life scenario, though. It'd be like in Jeopardy if they gave you 85 guesses. Kind of defeats the purpose of it. 90, 30, and 60, was it? That works, and it gives us 3 angles, comes out true, for 180 degrees. That makes sense. That works. The last section, finally. Inheritance. This is the last section, right? Thank God, last section. Inheritance. Finally, let's create an equilateral class that inherits from our triangle class. An equilateral triangle is a triangle whose angles are all 60 degrees, which also means that its 3 sides are equal in length. Create a class named equilateral that inherits from triangle. Inside equilateral, create a member variable named angle, set it equal to 60. Create an initialized function with the only parameter self, set angle 1, 2, and 3 equal to self angle, since equilateral triangles will always be 60 degrees. Remember, inheritance looks like this: class derived, class base class, where derived class is the new class you're making and base is the inheritance class. Okay. Now, should I put it above the print statements or below? I'm going to do it below. It'll be fine. It'll be okay below. No. Screw that noise. We're going to do it above. We're creating a new class. It doesn't matter. Create a class named equilateral triangle. Class equilateral triangle. Inside equilateral, create a member variable named angle and set it equal to 60. Copy angle equals 60. Create an initialized function with only the parameter self, angle 1, 2, and 3 equal to self angle. Define, you know what? It's going to be the exact same as this dude right here. Copy this bit. However, the difference though is create an initialized function with only the parameters self and set, self dot angle 1. Self dot angle 1, 2, and 3 equal to self angle. Now this bit, I don't know if I'm supposed to do 3 self angles or if I'm just supposed to do all 3 on one line. I don't think I can do all 3 on one line. And self remember inheritance looks like this, where derived class and the base class and the blah blah blah. Let's give this a go for now. Your code looks a bit off. See the console window for the full error. Python, line 21. Define self angle 2, 3. Self dot angle 1. 2 and 3. Maybe it's like... Don't mind me, we're gonna put self back. So those are definitely spelled correctly. Maybe it's the if statement. Very much like this. If self angle 1, 2, and 3 equal that. We'll give it another shot. We're gonna do set, create, and initialize function with only the parameter self. That self angle 1, 2, and 3 equal to self angle. It says the only parameter should be self. But that seems so strange. Oh, but because they're all the same, it works. That's what's going on. Ta-da! Dee-dee-dee-dee-dee-dee. You earned a badge. Introduction to classes. Okay. Very clever. Very clever. So class. So what exactly happened? Class, equilateral triangle. Angle equals 60. Define. Initialize self only. We do have self angle 1, 2, and 3, but they all equal self dot angle because they all equal 60 degrees. That's what's going down. So for oh man, you had no idea how hard this is for me. I want to help so badly. Did it? It was close. Yeah, we'll get there. It's just, you know, slower. We've got the capacity to figure it out. It's just timing. Good to watch people struggle. If you've got better things to do, then, you know, obviously helping out is good. That speeds up the process, but to each his own. But yeah, we made it out of the woods alive. Not bad. 18 sections down. We're going to take a peek at classes, make your own car, and learn how to drive car. Interesting. Let's take a gander. Ooh. 11. It's 9:47. What to do? What to do? Well, we get to read through the beginning anyways, right? We can peek. Class basics. Classes can be very useful for storing complicated objects with their own methods and variables. Defining a class is much like defining a function, but we use the class keyword instead. We use the word object in parentheses because we want our classes to inherit the object class. This means that our class has all the properties of an object, which is the simplest, most basic class. Later we'll see that classes can inherit other more complicated classes. An empty class would look like this: class, class name, object. Class statement goes here. Instructions. Define a new class named car for now. Since we have to put something inside the class, use the word pass keyword. Hold the phone. All right. We're pushing on. We're so close to the end. I don't think we're going to complete section 12, but I think we're going to complete section 11. After 18 units, and there's only 11 in this one, I think I'm going to keep pushing on. Okay. Class basics. All we have to do is define a class named car and just put pass under there, right? That's basically it. Class, car, object, pass. Did you just ask the boss if you could keep going? Absolutely. Well, technically more of a food check, because when did we last eat? It's 9:51 now. We last ate around 4. She's snacked though, and I haven't. So as long as everything is right in the world with her, then we've got free reign. Alright. Here we go. Pass. I think that's all that's needed. Check. Golden. That and water. After how long have we been streaming for now? 2 hours and 15 minutes. Without being able to breathe. Water helps though. Okay. Create an instance of a class. We can use classes to create a new object new objects, which we say are instances of those classes. Creating a new instance of a class is easy as saying new object equals class name. Below your car class, create a new object named myCar that has an instance of car. So my car equals car. Does that seem right? That seems... Yeah, that works. That's a thing. That is a thing. Class member variables. Classes can have member variables that store information about each class object. We call them member variables since they are information that belong to the class object. Creating member variables and assigning them initial values is easy as creating any other variable. Well, totally jumbled that up. Creating member variables and assigning them initial values is as easy as creating any other variable. Class name, object, member variables, initial value. Inside your car class, replace pass statement with a new member variable named condition and give it an initial value of the string new. Condition new. This so far was a good decision. 4 out of 11, but let's not hold our breath. Calling class members variables. Each class object we create has its own set of member variables. Since we've created an object, my car, that is an instance of the car class, my car, should already have a member variable named condition. This attribute gets assigned a value as soon as my car is created. At the end of your code, use a print statement to display condition of my car. Hint, since your attribute condition belongs to the object my car, you'll need to use dot notation to access the object's member variable, my car dot condition. Print my car dot condition. That all that's needed? No. Next. This is great. Lots of instructions. Not cool. I sense danger. Of course, as soon as we get halfway through it, it takes a hard turn for the worst. Well, let's see. Maybe it'll be something easy. Okay, initializing a class. There's a special function named initialize that gets called whenever we create a new instance of a class. It exists by default even though we don't see it. However, we can define our own initialize function inside the class, overriding the default version. We might want to do this in order to provide more input variables, just like we would with any other function. The first argument passed into initialize must always be the keyword self. This is how the object keeps track of itself internally, but we can pass additional variables after that. In order to assign a variable to the class, creating a member variable, we use the dot notation. For instance, if we pass new variable into a class inside the initialize function, we would say self.newVariable equals new variable. Define the initial function of a car. Define the initialize function of the car class. Take 4 inputs: self, model, color, MPG. Self, model, color, and MPG. Assign the last 3 inputs to member variables of the same name by using the self keyword. What? Assign the last 3 inputs to the member variables of the same name by using the self keyword. Oh, self.model equals model, self.color equals color, blah blah blah. Then modify the object my car to provide the following inputs and initializations: model, color, DeLorean, model, color, MPG. You don't need to include the self keyword when you create an instance of a class because self gets added to the beginning of your list of inputs automatically by the class definition. Hint, creating an instance of a class with many initialization variables looks the same as calling a function with many inputs. Put all the values in parentheses separated by commas in the body of the initialize. You'd set the model like this. Define initialize self model color mpg self.model equals model. Holy hell. Okay. Dear God. What are we doing? We're initializing something, somebody, somewhere. Condition. I think we're doing it here. Define. Self model color mpg. Self dot model equals model. Don't mind me. Do 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 do. 1, 2, 3. Model color. Oh, you know what? I've actually got more than needed there. Model color mpg. Is there anything else? Define initialize function of the car class to take 4 inputs. Self, blah blah blah, all the way to mpg. Assign the last 3 inputs to member variables using the self keyword. Then modify the object my car to provide the following inputs at initialization. Uh-oh. Don't mind me. Hella sneezy. Face is exploding. We almost lost the webcam. Okay. This is painful. Something about my car. Modify the object my car to provide the following inputs at initialization. Model equals DeLorean. Color equals silver, MPG88. You don't need to include self. Can I just copy those? You don't need to include self keyword, but yeah. Let's see what happens. This feels wrong. I think I actually need to put it in car, but frankly, don't really give a damn. Don't really give a damn. Line 8 is the issue. Takes exactly 4 arguments. 1 is given. Self? Now what's happening? Hey, look at that. But there's beef with something or other there. How about no colon? I don't like that. I like the other code I was getting. self. I don't know what I'm putting. Well, you can get green check marks and not even have valid syntax. Yes, that is correct. That's another issue. So, because especially when, that's the other thing. I mean, I know you're here and you can spot what's wrong. I can kind of feel it, like a disturbance in the force, just because I've been doing it for the last, like, 60 days. I know something definitely isn't right. It seems, something just seems off. But for those who don't know, or who don't care, or whatever, like, how are they supposed to know? How are they supposed to gauge if they're just passing out green check marks for whatever there is? There's got to be more Q&A, I feel like, personally. That's just my thoughts on the issue. Alright, self something. I don't know, we're gonna take a quick peek at the forum. It is? I was thinking it would be that. DeLorean Silver 88. God, I just, that felt wrong in my mind for some reason. Don't know why. And that's why it was giving us beef. We don't need the colon at the end of that. Ta-da, and it spits out new. See that? New. All is right in the world. Gopher's got us covered. Okay, section 6. Referring to member variables. Calling class member variables works the same way whether those values are created within the class, like our car's condition, or values are passed into a new object at initialization. Blech. We use dot notation to access the member variables of classes, since those variables belong to objects. For example, we hadn't created a new member variable named new variable, a new instance of the class named new object could access this variable by saying new object.new variable. Instructions. Now that you've created my car prints its member variables, first print the model of my car, click stuck, get hint, for example, then print out the color of my car, then print out the MPG of my car. To print my car's model, you type print my car.model. Here we go. I think we're just doing printing stuff now. That's mainly what I walked away. That was the general vibe I got. Now that you've created my car, print its member variables. First print the model of my car. So my car.model. We're going to do print my car, copy. 1, 2, 3. Model. Color. And MPG. Boom. New DeLorean Silver 88. I like the Back to the Future reference, by the way. We didn't acknowledge that, but we've been thinking it for the last couple sections, so 88 miles an hour. Silver DeLorean, Back to the Future? No? We all got it. We got it. The people who care got it. Creating class methods. 7 of 11. Besides member variables, classes can also have their own methods. For example, class square object, define initialize self-side, self.side equals side. Define perimeter self, return self-side times 4. The perimeter class method is identical to defining another function, except that it is written inside of the square class definition. Just like when we define initialize, you need to provide self as the first argument of any class method. Okay. All right. So they're explaining why we still put self here for parameter, just like how we have self here for initialize. When you go to add a new function inside of a class, like define parameter, you still drop in self. Okay. Inside car class, there we go. We open the hint. Inside the car class, add a method named displayCar to car that will reference the car's member variable to return the string. This is a color model with MPG. You can use the string function to return your MPG into a string when creating the display string. Replace the individual print statement with a single print command that displays the result of calling mycar.displayCar. Hint, remember, in order to access member variables of a class, even while inside that class, we have to use the self keyword and dot notation to specify that we mean the member variable that belongs to the class. Blech. We're losing steam. We are losing steam. That's okay. Fight on. Inside car class, add a method named displayCar. Okay, displayCar will reference the car's member variables to return the string. It references the car member variable, I think self? And returns the string blah blah blah. Return. I think I'm supposed to put in the parentheses, or not parentheses, the percentage. Do we recall what I'm talking about? Percentage, comma S. Or not comma, apostrophe, percent, comma S. Percent, comma S. And then we've got like, God, I'm drawing the blank on the format, like percent something or other. And we do like model. I forget, we either type out model color MPG or we actually put in the actual variables. Which would be DeLorean, silver, although they'd be strings, silver, except the number wouldn't be 88. I'm gonna figure that out. I gotta figure out what the correct version or syntax is. If it just follows this, the example, or if it's closer to this, and what version. Model. But we'll get there. And then part 2, you can use the string function to turn your MPG into a string when creating the display string. So we're supposed to wrap somebody in string. It's probably this guy. We'll figure it out. We'll figure it out. You know, like string, but 88. We'll get there. We'll get there. Replace the individual print statements, plural, with a single print command that displays the result of calling my car display car. So we will get that configured. Print my car display car. Perfect. Topher's saying something. It's just %s inside the string. 1, 2% variable 1, variable 2. Okay. Percent model color MPG and then I think that's okay. We're gonna see what this gets us. Code's a bit off, need your help. Trace back. Line 13 is down here. And line 9, display car. Line 9, return this blank. Global name model is not defined. Interesante. Don't forget that you're referencing member variables. So you need the self dot model. Oh, damn. Okay. Self dot self dot model. Blah blah blah. We'll try submitting. Oh, we are getting there. Looks like you didn't print. This is a silver DeLorean with 88 MPG. This is okay. So I put them in the wrong. Okay, it's just the wrong order. That's fine. So color and then model. That's all. Boom. There we go. See that? We had model. I did model and then color because it was model and color up here. But they wanted color and then model for their statement. So that's that. Very nice. Okay. Modifying member variables. We can modify variables that belong to a class the same way we initialize those member variables. This can be useful when we want to change the value a variable takes on based on something that happens inside of a class method. Instructions. Inside the car class, add a method driveCar that sets self.condition to the string used. 2. Remove the call to myCar.displayCar instead of print only the condition of your car. Then drive your car by calling driveCar method. Finally, print condition. Okay. Let's do this. Let's just tackle them one at a time. They seem fairly straightforward. Inside the car class, add a method driveCar that sets self condition to the string used. Okay. Define drive car self comma self I want to do dot condition. Because conditions listed here. So there's no need to list it in this. So it's the same thing. We have self here. So all we need to do is self there. So all we have to do to reference dot condition, like so, is simply put it in there. So set self condition equal used the string used. That's how I interpreted step 1. Could be wrong, but we're going to continue on with 2, 3, and 4. In the meantime, remove the call to my car display car. We're going to destroy this and instead print only the condition of your car. That's just getting rid of all this noise. Then drive your car by calling the drive car method. Finally, print the condition of your car again to see how the value changes. So we need to just use drive car. And then after, print my car dot condition. So it should be new up here. Then it will drive. And then it should be used. I think that's how it should work. Code looks a bit off. Feel free to peek back at the last section. If you need help. Trace back. Line 18. Drive car is not defined. Do I need to reference condition? Maybe it's like this. Maybe I need to throw in used. Let's see what happens. Okay, that's wrong. Q&A forum. Section 8, modifying member variables. Section 8 of 11. We are right at the edge. Modifying member variables. 8 of 11. I think I got the correct answer, but I still show wrong. Oops, try again. You didn't display the used condition after drive car. New, used, none. My car dot drive car. Interesting. Already know why, just misspelled. Yeah. And I think we should be good, so just dot my car. Oh, and I should probably get rid of used. There we go. New, and then used. What's going down? Topher. My car dot drive car nothing. Okay, yeah, that's what Topher was saying. Very nice. Same as the forum answer. That's good. Confirmation is always helpful. 9 of 11. Oh, and we'll be done with section 11, and then there's only section 12, because I believe 13 actually isn't a Codecademy section. It's a do it on your own if there's time. Although it says upgrade and you have to pay for it. Don't worry about that. Focus on section 9. 9, 10, 11. Boom. Inheritance. One of the benefits of classes is that we can create more complicated classes that inherit variables or methods from their parent classes. This saves us time and helps us build more complicated objects, since these child classes can also include additional variables or methods. We can define a child class that inherits all the variables and functions from its parent's class, like so. Child class, parent class. New variable and functions go here. Normally, we use objects as the parent class because it's the most basic type of class, but specifying a different class, we can inherit more complicated functionality. Instructions. Create a class electric car that inherits from car. Give your new class an initialize method that includes a battery type member variable in addition to the model, color, and MPG. Then create an electric car named my car with a molten salt battery type supply value of your choice for the other 3 inputs: model, car, color, MPG. And redefine a method of child class is as simple as including a definition for that function inside the child class. This version will take the precedence over the inherited version. Remember to include the self keyword as the first input when you define the initialize method. Alright. I think it's going to be incredibly similar to what we currently have for a car right here. Man, falling asleep. We're so close, though. Can't wait to kill this python. Class. Electric car. Inherits from car. Define. Initialize. We'll have self. Battery type, a member variable, in addition to model, color. I don't know if I need to reference model, color, and MPG. We're already calling from the car class. So I think all I need to put is self and something equivalent to battery type, probably. Yeah. We're gonna go with that. Because that makes more sense to me than why would I have to retype out everything. I feel like that defeats the purpose of inheritance, right? At least that's my current gut reaction. So, battery type. Self dot battery type equals battery type. Then create an electric car named my car. My car molten salt battery type. Definitely slowing down. Molten salt. Totally missed the quotes on that. Okay. Supply values of your choice for the other 3 inputs. Okay, so I'm doing all of them. Damn. So Tesla black? Eesh. I don't even know what a MPG does. 65? Molten salt. That's my guess. We'll see. You're essentially overloading the parent class constructor, so you would need to pass model, color, and MPG arguments to the child class constructor. Think of it as passing these arguments through the child class, then into the parent class. Oh, so we're sending it back upstream. It's not that it's trickling down. Okay, so I keep re-entering. So I do throw in model, color, and MPG. As well as battery. And then it's going to take all this noise and pump it back into car, as well as run through all the other nonsense that we've set up before. Okay. Cool. Well, then that definitely should... Now, well, with that said, I guess I still need to do self-model mpg.color. Maybe not. I'm going to hit pull the trigger. If it blows up in my face, I'm going to add this stuff. It would make sense that I would have this stuff if I'm taking the time to put it in here, but to hell with that, right? So, fire away. My car doesn't have a model member variable, probably because of exactly what we were just discussing. So copy this. Now we'll throw it in from the top. Molten salt. Maybe you're just battery type? Ta-da! Dee-dee-dee-dee-dee-dee. Beautiful. Beautiful. All is well in the universe. Lesson 10 of 11. You're right there. Okay. Diddy 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 diddy. 10 of 11. 10 of 11. Overriding methods. Since our electric car is a more specialized type of car, we can give the electric car its own drive car method that has different functionality than the original car classes. 1. Inside electric car, add a new method, drive car, that changes the car's condition to car condition string Instruction 1. Inside electric car, add a new method, drive car, that changes the car's condition to the string like new. Then outside the electric car, print the condition of my car. Next to drive my car by calling drive car function. Finally, print the condition of my car again. Hint. Hints open. This should be very similar to what you did in the second exercise of this section. Agreed. So here we go. Inside electric car, add a new method, drive car. Drive car, self condition like new, copy. Like new. Then outside of your electric car, print the condition of my car. Print my car condition. Copy. Print my car condition. Next, drive my car by calling the drive car. This is very similar. I probably could have just copied all three of those lines. Finally, print the condition of my car again. Also, this should be above all that noise. There we go. Okay. Think of it as passing the argument. Now I'm second guessing initialize for electric car. For some reason, it feels like you should be able to just add battery type and nothing else. That was my initial gut reaction. That's why I only had self and battery type in there. That's, I figured, just with inheritance, but I mean, it makes sense the way you had mentioned it. I got the green check mark, and the way I originally had it before I changed anything, it shot me down. Now, that could have been due to the syntax of how I had it before adding self model and MPG, but again, but I don't know if Python works that way without explicitly calling the base class constructor inside the child class. It's exactly my point, and you're certainly smarter than the average bear, and definitely better at coding in general than I am, so even if you're confused or unsure, the fact that their instructions aren't clear enough to convey either to you, someone of your experience, or me, someone who has less experience, I think that speaks volumes about the quality, which is why I'm so concerned and frustrated all the time when I'm learning through this. It's been 60 days of hell. I've only made it this far because I am a certified crazy person. Self-certified, so, you know, I probably should get checked, but more fun just owning it as best as I can, but I digress. So, yeah, not too sure. What happens if you take out the model color and MPG, member variables, assign in the child class? We're going to find out. I'm going to pull the trigger to make sure everything is hunky-dory as is, which it is. New used, new like new. Whether this is actually accurate, though, we'll never know. And then let me take this bit out. Remove. Cut. And cut. There's that. Fire away. Boom. Hates me. Hates everything about me. Yeah, typical, right? Or my favorite, we do the in-between version. We run it with this, so nothing down here except for battery, and we still keep model, color, and MPG, but I feel like if they're listed here, then they should also be listed under as well, but we'll still run it. Doesn't like that. Close out that noise. We will do Z, Control Z, fits that up, and we'll do vice versa. Clear out this noise. Have all the noise under here, none of that. Run it again. Still hates me. So it's just us versus the machines. That's the difference. What happens if you take out model, color, and MPG arguments and member that's what we were talking about. Yeah. So it's bad juju all around. Yeah, good times. And it really doesn't make sense to get rid of these variables because they're kind of needed. Sort of like the DeLorean factor. So, yeah. That's all. That's okay. Brings us to section 11, which is the end of section 11 too, which is awesome. Good times, right? Building useful classes. Chances are you won't be designing car classes in the real world anytime soon. What little faith they put in us. Usually classes are most useful for holding and accessing abstract collections of data. One useful class method to override is the built-in Ripper function, which is short for representation. By providing a return value in this method, we can tell Python how to represent an object of our class, for instance, when using a print statement. That way the way they are teaching, this feels wrong in a way to me. Yeah, take that feeling, times it by 12, and that's what I've felt for the last 60 days. You've been here for the last 60 days. So, yeah. Because you've got the feeling of you know better. I've got that feeling of I don't know better, which is brutal. Because even I can still tell that it feels wrong, and I don't know better. So, yada to mean. Alright, here we go. The final instructions. Define a point3D class that inherits from object inside the point3D class. Define initialize function that accepts self x, y, z, and assigns these numbers to the members variables self x, y, z. Define a representation method that returns %d, 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 %self x, y, z. Oh god, phone. This tells Python to represent this object in the following format: x, y, z. Outside the class definition, create a variable named myPoint containing a new instance of point3D with x1, y2, z3. Finally, print myPoint. Hint: when defining a new representation, return a string value that uses the member variables of the class to display the 3D point properly. You can use the string function to put these numbers in the proper string. For advanced users, for more information on representation and other special methods, see this Python documentation. Note the slight difference between representation and string methods. Noted. And we're noting and we're opening. Yeah, beautiful. Hideous. Best way to teach? Data dump, right? Are you interested? Then you should read all of this. Oh my god. Here's 45 pages of advanced material regarding the subject that you just heard about literally 45 seconds ago. Oh my god. I don't know who they have at the helm of deciding how to teach people this, but They might want to question or reconsider. Maybe it's a seasonal hire. Maybe they can get someone for the next semester. I don't believe it's a semester-based position, but something to think about. Can I link this in chat? Sure, yeah. Definitely. Let's copy this. It's from the Python Software Foundation, for the US at least. So, you know, you need some light bedside reading for the next 47 years. We've got this. We've got this. The best way to get it to Topher is by sending it to myself. Bum 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 bum. Dun 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 dun. Dun 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 dun. Yeah da 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 da. Ding 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 ding. It's coming in. Just copying the link. Going through like 4 different devices just to get to you. Does that link work? That link does work. Beautiful. Beautiful. Let's close out this noise, close out of that. We will drop it in the chat. Boom. We sent it in chat, and I'm even going to send it through Discord as well. Beep beep ba dee dee, ba ba doo ba doop doo, dee 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 dee, be dee 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 doo. Love it. Love it. Oh, not a voice channel. Close. General. Based. There you go. Boom. You got hella linked. Hopefully that works out for you. Good? Thank you? No problem. Anytime, man. You kidding? That's the least I can do for you with all the help you give me. Good God. Oh, someone texted me 45 hours ago. Well, you know what? I'll respond to that. We're nearing the end of the stream. I'm just gonna conquer this, and we are on section 11 out of 11. So let's just finish this and get this nightmare over with. Defining, note the slight difference between repair and string methods. Yay! Okay, let's just do this. Oh. Here we go. Instructions. Define a point3D class that inherits from object. Copy. Class. Point3D object. Colons for life. Inside point3D class, define an initialize function self x, y, z. Assign these numbers to member variables. Copy. X, Y, Z, Y, Z. Define a repair method that returns blankety 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 blank. This tells Python to represent this object in the following format. Define copy Now, they don't state if I still need to include self in this. I don't believe I do. One useful thing in short representation by returning, they don't mention putting self in here, so I'm going to forego that. If it were anything other than representation, I would include it. I think it's just for when we initialize something, but who knows. In the meantime, let's do method. So representation method that returns D, and D for self XY. This tells Python full copy. Maybe I do put self because it needs something and it returns this. So return a string blah 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 with self X, self Y, and self Z. Outside the class definition, create a variable named myPoint containing a new instance of point 3D with X, Y, Z, and 3. myPoint create a variable name containing a new instance point 3D copy 1, 2, and Z3. I don't know if it actually needs to have the equals. I'm assuming it does because that's how they provided it. Then finally print myPoint. We'll see how this goes. What's Topher saying? Okay, so in the previous example with electric car inside initialize method, you could have done I was supposed to use super. You're right. I should have used super. Basically, you would be explicitly calling the parent class instructor and pass the argument to it. That's all I wanted the docs for, so I could sleep tonight without thinking about how to solve that. I should have used super. You are correct. Okay. Well, let me get through this. That may be a victory for another day. How does this work? Save and submit? Hot damn, I got it right on the first try, and it says we finished the classes. Close. Okay, so we succeeded on this. Close. I do want to take a look at, you were saying overwriting. So what needs to happen? Where do I put the super? Because we've lost all energy and interest and my eyes are going cross-eyed. So in the previous example with electric car class, inside the initialize method, you could have done super initialize model color. There's a super somewhere. Replace line 26 and 28 with the call to super. You got it. Super dot wait, replace lines 26 through 28. 26, 27, and 28. Super. D. Right, or is that still... Or are you talking about on line 25, add super? Like super on line 25. Yeah, I was doing it right. Okay, cool, cool. Super, parentheses, dot, initialize. My guess is I can get rid of this noise now. Battery type. And then, what should I be putting in? I should be putting in car, probably. That's my best guess, it's car. And my car does not appear to have an instance of electric car. Now you still need to pass the arguments to the initialize method. Car. Overriding. Like have all the self stuff? Remove the trailing comma after MPG on line 26. Oh, my bad. My bad. Line 32 module, line 26. Takes arguments 2, 3 given. Remind me, override 10. Overriding. Locked with a check. Nice. Electric car. Don't know what I should fix. Check the indentation of your drive car. That's where your problem is. Thank you. Can you explain the code below why it works? Used parent class car instead of self in the child. Oh, electric car self. Interesting. So electric car, comma, self. And we'll check this one as well. They did it the way we initially did it. They didn't utilize the super. Alright, so we'll drop in electric car, comma, self, and we'll see how that goes. Da 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 da. Topher. Okay, yeah, you were saying the same thing. Super electric car, comma self dot initialize model color MPG. Yeah, that's exactly what the forum was saying too. Very nice. Awesome. Okay, so it's down. 10 is correct. 11 is correct. We finish that. Up next, section 12, file input and output, which I'm definitely going to tackle tomorrow. Now that you understand Python syntax and have been introduced to some Python best practices, let's apply what you've learned to a real-world application, writing data to a file. We're going to close you and you and you. We'll read the little intro bit. See it to believe it. Until now, the Python code you've been writing comes from one source and only goes to one place. You type it in at the keyboard and the results are displayed in the console. But what if you want to read information from a file on your computer and or write that information to another file? Great question. That's only 9 sections. That's definitely something to save for tomorrow, although a short section. Yes, that's the way you do it in a real world scenario. Awesome. You're at 95%, which means I'm pretty sure that explains why section 12 is actually the last section with just the 9 to go. And the Python project has that weird upgrade thing to pay for it, which is still confusing because it says you're going to be leaving this environment to set it up on your own computer. So I'm not sure why I would be paying to kind of forge ahead my own personal product or project, but whatever. So section 12 is the last one. I'm glad to see that it's only 12 units, but that's definitely going to be saved for tomorrow, which is perfect timing in my book. Awesome. Way cool. Let's see where we stand. 658 points. 89 badges. Good times. This concludes day 60. We are backing out, closing down the stream. Golden. Golden. One more day of Python ahead of us. Let's close out this. Close out that. Little kitty is completely passed out behind us. All is well. Alright. Stop the stream. Topher, thanks again for all your help. Truly appreciate it. Good night, man. Enjoy the rest of your evening, and I'll probably see you tomorrow sometime. Alright. Sure you want to kill it? Hell yeah. Kill it.